after yesterday's notes and assignment, today's stuff is going to be pretty easy. Yeah, it's a little different, but it's mostly the same. Okay, here is the first problem, and you guys are going to tell me what to do, okay? I don't even think I'm going to have to teach this to you. That's how easy I think it's going to be. Yes. Okay. Tell me what I should do. Mm-hmm.
Oh, wait, since you're multiplying first, don't you have to simplify it and then multiply?
I wouldn't simplify first. So if you simplify first, this one couldn't really simplify first, but if it was one that could simplify first, what would possibly end up happening is you would simplify first, multiply, and then have to simplify again. So I would just wait till the end to simplify.
Because since, like, you're not multiplying them, like, individually,
Mm-hmm.
I thought that would be, like, 2.5 first. Like, if it was, like, a regular number, like, over here,
Mm-hmm.
I thought that's fine.
So with multiplying, it doesn't matter if they're like terms or not.
Okay.
You can multiply anything. Okay, so how do we multiply when we have parentheses and something in front of the parentheses? Starts with a D. Distribute. We're going to distribute. So how do I multiply root 10 times 5 root 5? You multiply the roots. So if this one had a coefficient in front, then you would multiply the two coefficients in front. So this one, I guess you could say that it has a 1. So you'd say 1 times 5 is 5. And then you would say root 10 times root 5 is root 50. Okay. And then when you multiply the second one, 1 times negative 2 is negative 2. Root 10 times root 2 is root 20. Okay. And then what should we do? Not combine the things outside just yet. Simplify. Okay, so 50 we're going to break down into what? 5 and 10. 10 breaks down into 2 and 5. Okay, so we got a pair of 5s and a leftover 2. 20 is going to break down to be 2 and 10. 10 is going to break down 2 and 5. So we got a pair of 2s and a leftover 5. Okay? So the first one is going to be 25 square root 2 minus, what's the second one going to be? Why aren't we doing anything with the what? We did. We put it underneath. And then over here we have 4 square root 5. They are not like terms, so we can't put them together. So we're done. Okay. We can't put them together because this is a root 2 and a root 5. And if we want to feel good about our answer, we can type in the original problem. Root 10 times 5 root 5 minus 2 root 2. And we can make sure that that decimal is the same as 25 root 2 minus 4 root 5. Decimals are the same, so we can feel good about that. It doesn't mean necessarily that we perfectly simplified it, but it does mean that we didn't like invent numbers that shouldn't be there. Cool. All right, let's try another one. All right, this one says 8 minus root 10 times 3 minus root 10. 8 minus root 10 times 3 minus root 10. How do we multiply these?
Like, what's the, like, don't you do like 8 times 3, like 8 times the radical?
Mm-hmm. So FOIL?
Yeah, that.
Yeah. Mm-hmm. So 8 times 3 is, and then 8 times negative root 10. Mm-hmm. Negative 8 root 10. Okay. And then negative root 10 times positive 3. Mm-hmm. And then negative root 10 times negative root 10. Positive square root 100. And what is the square root of 100? Just 10. Okay? So if we combine our like terms, what do we get? Yeah, minus 11 root 10. Can the root 10 be broken down at all? Just 2 and 5, and there's no pairs in that, so we would just leave it. Okay. Why don't I what? Yeah, because there's just ones and ones. All right. Let's do 6 root 6 minus 6 root 2 times root 6 plus root 2. I can already tell this one's going to be a pain with all those 6s and 2s. Okay, what should we do? Distribute, right? We're going to FOIL it out. Did you say FOIL?
Yeah, full.
We're just going to leave out the I.
I don't know what full is. I know foil is. Foil.
Y'all know you're gonna go to
So if you do the basics of foil.
So 6 root 6 times root 6. Okay. And then we have 6 root 6 times root 2. Okay, 6 root 12. Okay. And then negative 6 root 2 times root 6. Okay. And then negative 6 root 2 times positive root 2. 6 root 4. Okay. What happens with the middle terms? They combine, they cancel each other out. They actually make 0. Okay. What's the square root of 36? 6. So this is 6 times 6, which is 36. Okay. What happens over here? The square root is 2. So square root of 4 is 2. Negative 6 times 2 is negative 12. Okay. So we have a positive 36 and a negative 12. 24. You combine them. So yeah, we added them. Yeah. Mm-hmm. Yep, because the radicals canceled each other out, so we just had the whole numbers left. Okay. What about if I had 4 minus root 5 squared? Do I just square each term? You'd multiply it by itself. We write it out twice. Okay? And then when we multiply it by itself, what do? We FOIL it. So we have 4 times 4 is 16. 4 times negative root 5. Negative 4 root 5, okay. Negative root 5 times 4. Negative 4 root 5, okay. And then we have a negative root 5 times a negative root 5. Positive root 25. Okay. Root 25 is just 5. So what do we have? So 16 and 5 is 21. And then negative 4 root 5 and another negative 4 root 5. Do they cancel out? They're both negative. Do they become positive? It's negative 8. So it's 4 negatives and another 8 negatives combined to make 8 negatives. So negative 8. So it was multiplying to start with because the parentheses were written right next to each other. But now we just have all these terms written down that are being combined together. And these are 2 negative terms being combined together. So we just add up all the negatives that we have. So we had 4 negatives and 4 negatives that we're adding together. And so 4 negatives and 4 negatives makes 8 negatives. And we're combining like terms. Does that make sense? Okay.
And you don't combine inside the root, square root?
We don't combine in here because these are not like terms. But if we had like terms in there, we could have combined them. We just haven't had any problems where there have been like terms inside that we were able to combine. Like if you look at this example, it was a root 6 and a root 2, and those are not like terms, so we couldn't combine them. These are not like terms, so we couldn't combine them. Regular number or root 10, those can't be combined. So that's why we haven't been able to do anything inside the parentheses, because none of them have had like terms to be able to add. Yeah. Okay. Let's look at a couple with some variables, and then I'll let you guys finish your worksheets. So we've got root 3k multiplied by root 12k minus 2 root 15k squared. So we've got something in the front of a set of parentheses. What do we do? So what's underneath the radical? So k squared, what was the number? 3 times 12 is 36, okay. Oh, I got you. And then when we multiply these two together, what do we get? Anybody know? 45k to the third. What do we do with the 2 in the front? So we're taking this and we're multiplying it by both of these. Anything that's underneath a radical multiplies underneath the radical. So there's a 1 in front here, and we would just do 1 times 2 is 2. So whatever's in front of the radical multiplies by the front. Whatever's underneath multiplies underneath. So we multiplied the underneath here to get this. 3 times 12 is 36. K times K is K squared. 3 times 15 is 45. K times K squared is K to the third. Okay, so now we just have to simplify. Can we simplify the square root of 36? That's a perfect square, right? What is that? 6. What about the K squared? That's just K. So this one was like perfect square. The whole thing was a perfect square. Okay, this one's not though. So what should we do with the 45? We're going to break it down. How can we break it down? 5 and... Okay, the other option was... We had 15 and 3, right? That's what we multiplied to get 45 to begin with. So we could do 15 and 3. And then 15 breaks down to be 5 and 3. Okay. So we have a pair of 3s and a leftover 5. And then what should we do with the K's? We got 3 of them. Okay. And what do I do? Got a pair of them, got a leftover. So what should I write now? 6. Okay, 6. Keep the negative. Negative 6. Is it a K squared? Just a K. And then what's left underneath the radical? 5K. Okay, so the final answer is 6K for the beginning minus 6K with the radical 5K.
How could it be 5K if it's not fair? Like on the outside, there's more K than it is in the inside.
I was confused about that too, but you're looking for a pair. You only have one pair, which means it's just K. The only reason it would be K squared is if you had 2 pairs of K's.
So what this means right here, when I circle and I say there's 3 Ks and I circle 1 and I say that this means there's 1 on the outside and 1 underneath, when I do this, what it means that I did is it means I did a shortcut and I said that these pairs are the square root of K squared and this is a leftover K. What's the square root of K squared? K. So that cancels, and it gives me K root K. I'm just saving you from showing that work in the middle. So every time I have you circle a pair, basically what you're doing is you're taking the square root of that pair squared. That's what you're doing every time you circle a pair. You're just not showing the work. So K squared, square root of that is just K. That's why we were able to put 1 out front, not 2 out front. Is because we were really doing K squared and then putting a square root over it. So all of these had a square root to start with. We just simplified one of them and it came out to the front. That's why it's out there. So this K out in the front actually represents 2 of them. It would be 2 of them if we put it back underneath the square root sign. Yeah. Okay. How do you guys feel about those problems? So if we look back at the worksheet, at the last 4 problems on the worksheet, could we do those last 4 problems? Yes? Okay. So the goal is in the next 35 minutes, finish the last 4 problems on the worksheet, do any of the problems on the worksheet you might be missing, and then get them turned in. And then if you have any missing work at all, you can work on any missing work you have.
Do you have another copy of that worksheet?
I would look over on the table all the way to the right.
So I did last night, so I'm like a piece of notebook paper, I just did everything right.